Hello, Honors Chemistry. Today we're going to be doing a lab activity. As you can see, it's lab number 11. I'm not sure if it's 11, but today it's 11, so don't get out an argument with me. It's lab number 11. The name of the lab has to include the following words. It has to have acid egg and base egg. The only materials you're going to be using is 3 fresh eggs, 250 milliliter beakers, some water, white distilled vinegar, and bleach. Okay, now I'm just going to be talking about worms there for just a second. You're like, what is he talking about worms for? Actually, even though this is not a scientific thing, it's kind of the way I would teach this in class as well. If you think about an acid is something that will dissolve everything. If you put a pot with a bunch of tomato sauce burn in it and you used acid to clean it, it would definitely eat off the tomato sauce, but it would also eat the insides of the pot. However, a base is a little bit different. The base, you put it inside there, it will actually, it's almost like little microscopic worms that tries to find an opening, the way to separate the tomato sauce from the pot. The stronger the base, the stronger that worm is going to be acting. So I bring that up just to show you that, to kind of give you an impact of it. Like acid will dissolve everything. A base will try to find any little opening. Really strong bases could actually get into the pores in your skin, go into your blood system and everything else. So they're extremely dangerous as well. So don't think of acids as the only dangerous one. Bases are very dangerous as well. Okay, now the first demonstration I'm going to show you is an old egg versus a new egg. I have my neighbor has some chickens in his backyard, and he has some very fresh eggs. I'm going to see if it'll work. I don't know what's going to happen today, but I've got an old egg that I've had for a while at my house. Not too old though, but it's about at least 2 or 3 weeks old. And then the fresh egg was laid about 2 hours ago. So we'll see how it goes here. So there I am. Here's the plate. Here's the fresh egg. I mean, not the fresh egg. This is the egg that's been around for a long time. What happens with the eggs that have been around a long time is the white in the egg gets really, really runny. And the reason it gets really, really runny is because the proteins start to break down in it. So let's see if you can see that at all. Can you see the egg? Maybe. Let me see if I can. Oops. See how runny that egg is? That is an egg that's been around for a while. Let's see what the brand new egg looks like. It's almost gonna. It should look almost like a pyramid there. This is a different type of chicken, so you'll see it's actually a little green egg, believe it or not. He has a chicken that lays green eggs and one that lays blue, and there's one that lays like little light orange eggs. It's kind of strange, but they're just different breeds of chickens, okay? Now take a look at this yolk here. Look at this yolk. See how fresh it is? It's sitting up. If you could look at it from a better angle, it doesn't stretch out very far, spread out. It sits up almost like a pyramid. A nice, pretty egg. That's what a real fresh egg looks like, okay? And that's because the proteins have not started to dissolve yet. That's something you would learn in food science, but still yet that is part of what we're doing anyway. So what I did though is I took 3 eggs, 1 fresh egg, and I put it into water. And one of the 250 milliliter beakers, I put one of the fresh eggs in there, and I put water in there until it comes up to 200 milliliters and let it sit for 72 hours. Then I took 1 egg and I put it in the same water, the same type of beaker, fresh egg, and I filled it up with 200 milliliters of water until the total level of the water was 250 milliliters, 200 milliliters rather. And there's the egg afterwards. You're going to see what it looks like on the inside. This is the experiment I told you, a little bit dangerous because of the poisonous gases that could form. Here is the egg that I actually put 200 milliliters. And remember, the vinegar egg is actually an egg in acid. And the bleach egg, this one actually went all to 200 milliliters. But the problem with this one was, when I first put it in there, the egg was floating on the top. Please mention that in your lab report. You should know the reason why. But anyway, this is after 72 hours as well. All 3 of these eggs were sitting in their solution for 72 hours, 3 days. Okay, let's go to the next slide here. Okay, we're going to talk about the egg in water. Like I said, first we're going to be looking at is the egg in water. The water we know is neutral. You sit there for 72 hours. Let's see what it looks like. So let me go back and do my picture again. Here we go, the water. If I can keep from making a mess, I'll be lucky. Got the egg. We'll dump that water out, so I won't have to worry about it. Just want to make sure I don't mix the water, the vinegar and the bleach though. So here's the egg. That looks just like the egg, like it did before. It's hard, same as it was. I don't see anything different. The fluid was completely clear. I forgot to say that it was completely clear. You didn't see anything. And I'm going to open it up and see what the egg looks like. Cracked it open. Let's see what it looks like on the inside. Whoa, almost made it on my computer. Okay, it looks like the egg we did before, the older one. This sort of, you see that? It's a regular egg. You don't see it. The yolk sits up nice and pretty and everything. That's the egg in water for 72 hours. That should not have been a surprise for you. Now let's take a look at the egg. These are going to be a little bit of surprise maybe for some of you. We're going to take a look and let's go back to the thing again. And now we're going to do the egg in vinegar, which is an egg in acid for 72 hours. Like I said, the acid is going to be dissolving everything. So let's put the spoon down so that you see it. Boom, right here. Taking the egg out. It's disgusting, yes. If it was in a classroom, it'd be all of y'all making all these smells. It's a humongous egg now. It grew big. It's big. It's squeezy. There's no shell left. The shell was completely dissolved. It dissolved inside the entire solution there. But the inside of the egg, the membrane is still there, but it's like a big ball. But now I'm going to burst it. Let's see if I can do this without making a big mess. Now the egg is coming out of the inside. Here is the membrane on the inside of the egg. It's like and it's almost the same texture of a balloon. No shell was left. Remember, this is the membrane. That's all it was, and it was swollen. So this is the egg that was in the vinegar. So the vinegar dissolved everything. It actually dissolved the shell of the egg. The shell of the egg was gone. Now what I'm going to do is I'm going to take that bowl away because it does have vinegar in it. I do not want to get the vinegar mixed with the bleach. I don't want to be dead, at least not yet. I know some of y'all thinking he's getting there, but that might be true, but let's keep it to yourself. Okay, let's keep going. This is the egg in the bleach now. Bleach is a strong base. Let me go down on that thing there for you. So now we're going to be dealing with the egg in the base. The bleach for 72 hours, the same thing. Take that out. Oops. Let me turn the light on for you. I mean the video on for you so you can see. Sorry about that. I took the egg out of the bleach. It still has the shell. This would be like with the worms. But if you look at the bleach, it's all obscure. It's got, if you look really close, I don't think you can see that from there. They have like little bitty white things floating all around in there. What that is actually those little worms of the bleach, and really not worms, but the bleach actually went through the little pores inside of the eggshell and dissolved the whites. And the whites were coming out into the fluid itself. So this is the bleach. I can already feel my fingers burning a little, so we're good. Now I'm going to burst the egg. You want me to see a whole lot of difference, but there should be a difference in the egg as well. Hopefully you heard that. That sounds really good. Crack, crack, crack. You don't see it too much here. Yeah, you'd see it more in the school. If you can barely see it, but the yolk is kind of slightly bent down or whatever you say. It's not quite as pretty and straight. In other words, it's already spread out. The yolk is all over the place. And it's also got some of the yolk is kind of almost like, it looks like it's deflated a little bit, okay? So that's kind of what you see. Now let me put this down before I make a real mistake and kill myself. So now we've got the 3 eggs. We did the 1 egg in the water. We did the 1 egg in the vinegar, which is the acid, and the one egg into the bleach, which is the base. What else did I have to talk about? So your assignment, don't forget you have to write about that, why the egg floated in the bleach. And it was at the bottom in the water, and it was in the bottom in the acid. But your assignment is to use the lab worksheet that was provided on the other lab that we did on the 31st of March. Use that worksheet to use. And also use the lab template that we covered the first week of school so that you can get your lab report done correctly. Everybody understand that? Well, that's not what I wanted to show you, sorry. But that's good enough. That was a joke picture for my grandkids. I did it again. I don't know what I've got there. But anyway, I'm not going to try another one. I'm almost afraid what's going to come out. But anyway, take care and get your lab report done. Remember the Friday's activity, I'm going to give it to you tomorrow, Thursdays and Fridays both. You need to have that Friday activity completed and turned in by noon on Friday because I have a report that's due to Mr. Colbert. So y'all take care. I miss all of y'all. Y'all take care and y'all stay safe. Thanks again. Be happy and stay safe.